Okay guys, we're gonna do parabolas today, and out of the things we've done so far, parabolas are the easiest. I don't know if it's because we've done so much conics, but now the parabolas, by the time we get to them, you guys have kind of got the concept pretty well, and today's lesson will go very well. So a few things before we start though, I want to talk about some parabolas and the nature of them and their equations, okay? So just a few things first. And here I'll start with the equation of a parabola. It looks like y equals a times x minus h squared plus k. That is the standard form of a parabola, okay, which makes sense because the parabola is y equals, something squared. When we graph it on the calculator, we graph parabolas all the time. What shape is a parabola? Right, a U, okay? So, and if you have an equation and it's set up like this, here is it, let me do it for you with numbers. So for example, if you would rather see something with numbers, it would look something like this. Okay, so that's kind of the same thing. When you have a y in y equals form, your parabola will either do one of two things. Okay, if this 2 in front is positive, which direction do you think it's going to open? Good. So it'll look like this. It'll open up. Okay, if this 2 in front is negative, which way do you think it opens? Down. All right. And the way that we've talked about that before is if it's in, and we'll divide this for a second, if A, or in other words, in this case 2, if A is positive, so you have a positive A, then you open up. If you have a negative A, you open down. So just by looking at this, first of all, let me ask you, what is A in this case? What's A in this particular equation that I wrote? 2, right? A is 2, okay? And since 2 is positive, this parabola would open up. Okay. Now, the other side is instead of it being a y equals, you sometimes will have it written with an x equals because all parabolas don't open up and down, right? They could open left and right. So if it doesn't say y equals, it might say x equals, okay? And if it says x equals, it's going to look like x equals a y minus k squared plus h. That's standard form. Now in this problem, if you'd rather see the numbers, it would look like y equals 2 times maybe y minus 4 plus 5. Oh, thank you. That should say x. Okay. So it should say x equals. Now, if it leads with an x equals, instead of opening up and down, they open left and right. Okay, so your picture would maybe either be this direction for left and this direction for right. Now, if you have a positive A, guys, which way do you think it's going to go, left or right? Right. Good. It opens right. And if you have a negative A, which way do you think it's going to open? Right. Correct. It opens left. Okay, so that's kind of it in a nutshell. Now, the next thing, I want to draw a picture of a parabola for you for a second. And in everything else that we've done, we know that, for example, A is important because it's the distance from the center to the end point, right? B can be important sometimes because it's the distance from the center to, on an ellipse, to the minor axis, right? And we also every time have to find C, correct? Because C is the distance from the center to the foci. And we find C from where? What two things do we use to get C? We can use A and B, right? That gives us a formula for it, all right? So that's kind of like this. We Okay, when you draw, let me rephrase that, when you draw a parabola, I'm going to use this one for example. Okay, this is my vertex, and let's say this is my foci. Okay. The distance from V, the vertex, to your foci, in other words, how much you slide, is actually called, in a parabola, it's called P. It's called P. Now, look back at our original formula. So the distance from the vertex, in other words, how much are you going to slide? Are we going to slide C? Do we slide A? Right? It's different in different ones. In a parabola, it's called P. But if you look back at your formula, does it give us a letter P? There's an A, here's an H, there's a K, bunch of stuff. Is there an actual P? No. So just like there's no C for an ellipse or hyperbola, we have to derive it. We have to derive P also. And where you get P comes from A, right? Which A is this, the number in front. So here it's 2, and here it's also 2. So this is the formula for it, okay? The formula that they give us is that A equals, okay, A is the number in front, 1 over 4P. Now, keep in mind, the 4 and the P are both in the denominator. It's not 1/4 P, it's 1 over 4P, very different. Okay, so this is the formula. I know the distance from the vertex to the foci is P. And I know A equals 1/4 P. Well, I don't need A. I know A. Look, A is always going to be given to me. 2, whatever number is in front here. I need P. Okay? So can you do me a favor and try to solve this for P? It's like a SAT question or an algebra question. This says A equals. Manipulate this equation so that it says P equals instead. Try it. Manipulate the equation so it's a P equals instead of an A equals. Okay, so the first thing I think you should do, or one way to do this, it's not going to be the only way, is I'm going to multiply this by 4P over 1. And whatever you do to one side, you have to do the other. So this, on the right side, the 4P's are just going to cancel. And all that's left on the right side is a 1. Correct? And on the bottom, these are multiplying fractions. So you're going to have 4AP or 4PA, however you want to list it. But my goal was to solve for P, because P is the distance from the vertex to the foci, how far I need to slide it. So P, you would divide both sides by 4A to get rid of them. So P is actually 1 over 4 times whatever they gave me in the formula for A. So this was the original, and this is my converted answer that you'll use. You'll use that a lot. Okay, it will give you A every time. Okay? So let's try a problem or two. So get your notes out. Okay, and let's fill them in. Here's your first one. They're very easy, guys. Looking at the problem, the first question it asks us is the direction. So which direction is that one going to open up in? Very good. What direction? Right, look at, this is A, and A is positive. It's also a Y equals. Y equals means up and down, so it's going to open up. Now the vertex comes from looking at the problem. Can anybody guess the vertex? Be careful. What do you think it's going to be? 3, -2. If it's in the parentheses, you take the opposite, remember? And the one over here stays the same. So this is 3, -2. And we know A is the number in front, so what's A in this case? 4. And we found a formula to make P easy. So P is actually just 1 over 4 times whatever A is. So P is going to be 1 times 4 times 4, which is what? 1/16. Okay, guys, remember P is the distance from your vertex to your foci. So let's graph our vertex first. So 3, -2. There's my vertex. And it says in the problem that we need to open the parabola up, so you can draw your parabola, just sketch a parabola. And we have to find the focus. How far do we slide the focus? Yeah, 1/16. And we know it's gonna be up, because it's inside of the parabola, right? So you're just gonna go up a tiny bit, okay, and it barely will fit. There's your focus. Okay? Now, you end up, let's find the formula for the, the point for the focus. So here's my ordered pair, and let's think about this for a second. I slid that point up, so I adjusted the y, didn't I? How much did I adjust the y? It was, here I am. I went over 3 still, so I'm still at 3. But instead of being down here at -2, I went up a little. So I want to take my -2 and go up 1/16. You can use your calculator, -2 plus 1/16, and then turn it back into a fraction. So I'm at -31/16, which is approximately -1.9. What? Yeah, -31/16. Now, my next question is the axis of symmetry. Okay, let's draw it first. Here's your axis of symmetry. Remember, it goes right through the vertex, doesn't it? And it's always a line. The axis of symmetry is in line, and it crosses right through the x-axis at 3. So it's x equals 3. Pretty easy, right? Okay, let's go to the next one then. Number 2. This is an x equals, guys, and a is -3. So if it's an x equals, we know it opens left and right, and it's a negative. So which direction is it going to open? Left. Okay, its vertex is what's going to throw you off. You may want to guess the vertex. Good job. This is with y. It's 4, -2. Be careful. Okay? The vertex is 4, -2. A is -3. Remember, we find P by taking 1/4 times A. So P equals 1/4 times -3. So it's -1/12. So you're going to slide down 1/12 or left 1/12. Okay, let's see. 4, -2. It's here. I'm going to open it to the left. Sketch a parabola. Now we have to put in your foci. Your foci is moved left 1/12. So right here. Just right inside the vertex. Okay? So now let's find our new point. The point of our focus, I'm sorry. So if you think about this, I slid it left and right. So which value changed? I was at 4, -2 down here, right? And I'm going to slide it left. So does that change the 4 or the -2? It changes the 4, because I'm moving left and right. So now I want 4 plus a -1/12, which in your calculator gives you 47/12. But I didn't slide it up and down, so I'm still at -2. Now draw your axis of symmetry. Don't forget to draw it. And then tell me what it is. What is the axis of symmetry? An x equals line or a y equals line? Crosses the y, so it's y equals -2. You'll notice, look guys, look what happens. -2, -2, -2, they're all the same. Okay, so we're going to move to problem 3. What's wrong with this one just by looking at it right now? We need to move the what over? Yeah, move the 3 over. So we're going to rewrite this as y equals -3 times x minus 1 squared plus 3. Move the 3 over. Okay, it's a y equals and a negative 3. So y equals is just a regular parabola, up and down. And if it's negative, which way is it gonna open? Which way?
Down.
Down, thank you. And the vertex is gonna be opposite 1 and the same 3. A was given to us right here, A is negative 3. And define P once again, P equals 1 over 4 times whatever A is. So P is 1 over 4 times negative 3. So again, P is negative 112. If we graph it, it's gonna open down. So our focus is right here, just a little bit below it. Okay, so let's make the point of the focus. Let's name the point of the focus. So here it is. Let's think about this for a second. I was right here. Maybe you don't understand this very well. Watch again. I was at 1, 3, and I slid down. What did I affect? The 1 or the 3? If I slide up and down, is that X or Y? Y. So it affects the 3. So the 1's gonna stay the same. And instead of being up here at 3, I slid down 112. So I want 3 minus 112, which gives me 35 over 12. And the last thing for you is the axis of symmetry. Draw it, and then name whatever it is. Is it an x equals line or a y equals line this time? Crosses the x-axis, so it's an x equals what? 1. And you'll notice, look, 1, 1, and 1. Okay, last problem, number 4. I'll let you start. Find me the direction and the vertex. Okay, so it's an x equals, so it's gonna open left and right, and A is positive. So we're gonna go with right. Be careful about the center again. The center is -2, -1. Should I get the center right? Okay, now then A is 1/2. Remember, we find P by taking 1 over 4 times whatever A is. So P equals 1 times 4 times 1/2. Well, half of 4 is 2. So P is 1/2. If you graph it, -2, -1 is here. We're gonna open to the right. We're gonna slide our foci 1/2. So here's your 1/2. So our ordered pair, okay, was at -2, -1. I slid to the right, which affects x. So I want -2 plus 1/2, which gives me -3/2. And I didn't slide up and down, so it stays at -1. Your axis of symmetry goes right through it, goes through the y-axis, so it's y equals -1. And then we'll just do the same. Okay, now you can work on your homework.